For this video, we will continue with power plants lecture. The next topic is cogeneration. Okay. So usually when we say power plants, diba, ang products natin ay electric power. Pero may times na hindi lang electric power yung product ng power plant, pero ginagamit din yung heat, okay, for other purposes. And it's called a process heater. Now, an ideal steam turbine cogeneration plant, instead of condenser, pinalitan niya ng process heater. Therefore, walang reject heat, may walang waste heat kasi nagagamit siya as a process heater nga. Ano ba yung process heater? For example, kailangang i-heat yung molasses sa isang sugar plant. Instead of gagamit ka ng heat na galing sa kuryente, 'di ba? Gamitin mo na lang yung waste heat from your power cycle, from your power plant. So, hindi na siya talaga quote-unquote waste heat kasi nagagamit na siya for the process. The ideal steam turbine cogeneration plant described above is not practical because it cannot adjust to variations in power and power heat loads. Pero a more practical but more complex cogeneration plant would be steam is extracted from the turbine at some predetermined intermediate pressure and the rest of the steam expands to the condenser pressure and it's then cooled at a constant pressure, and it's widely used in the sugar industry. So we have now a new definition, yung utilization factor. Hindi lang kasi, para siyang efficiency, pero hindi lang kinoconsider yung network output, but also yung process heat delivered. Okay. So, ganun na siya. Work net plus process heat delivered over Q in. Mas mataas na ngayon siya kasi ginagamit mo na ito. This is the diagram of a cogeneration cycle. So, we have, katulad siya nung regeneration na diagram. Kasi tingnan nyo. Pero, yan, meron siyang high pressure turbine at saka low pressure turbine. Doon sa high pressure turbine, in-extract yung partially yung steam na gagamitin sa to heat a process. Yan. Doon sa low pressure turbine naman, fully nag-expand yung steam. Yan. We also have a binary cycle wherein meron siyang dalawang working fluid. Bakit natin ginagawa yon? Kasi a good working fluid would have a high critical temperature. But critical temperature above what is metallurgically allowed, kasi ito yung 620 degrees Celsius yung metallurgically allowed temperature, makes it possible to transfer the portion of the heat isothermally at the maximum temperature. Pero ang critical kasi temperature ng water, if yun yung working fluid mo ay 374. Now, usually water naman talaga yung ginagamit kasi it's readily available, it's non-toxic. Pero hindi siya yung ideal. It's far from being the ideal one. So, ang gagawin na ang solution doon ay gumamit ng binary cycle. Yung binary cycle replaces water during the high temperature process with a more suitable fluid. So, ang result is a combination of two cycles. May high temperature region and may low temperature region. Yung high temperature region is also called the tapping cycle and the low temperature region is called the bottoming cycle. Ano yung example ng working fluid dun sa high temperature cycle? We have mercury, sodium, potassium mixtures. And ang disadvantage, of course, high capital cost. Kasi nga, kailangan mo ng fluid na, kailangan mo ng fluid na na kaya i-handle yung high temperature cycle. So, ito yun. Yung water na fluid dito sa ilalim, sa bottoming cycle. Yung mercury, for example, yun yung other working fluid natin, nandito sa taas. Pansin nyo na yung condenser ng mercury, yung boiler ng water. Pero in essence, heat exchanger yun. Siya yung parang naging boiler nung water. Yung condenser nitong mercury. Yun. Merong heat exchanger. So, ito yung high temperature process. Ito yung low temperature process. We also have the air standard power cycles. Kasi in gas power cycles, working fluid remains as gas throughout the entire time. So, saan applicable to? Sa spark ignition engines. So, we have these spark ignition engines, diesel engines, and conventional gas turbine engines. Dito naman, hindi water yung working cycle mo at hindi kasi nagiging liquid yung working fluid pala. Yung working fluid mo hindi nagiging liquid. Nag-ano lang siya, it remains as gas throughout the entire time. And during combustion process, air and fuel react to form the combustion gases. Kaya sila tinawag na internal combustion engine. Yung combustion products, they also serve as the working fluid. Yan. Kasi yung sa dinidiscuss natin na Rankine cycle, diba, hindi naman natin pinapakailaman yung combustion gases. Nasa boiler siya, pero hindi siya kahalo nung working fluid natin na water. Nasa ibang container siya. Ibang reactor siya. Pero yung heat na nandun sa combustion products, yun yung ginagamit natin doon sa boiler para i-heat yung working fluid na water. Pero dito sa air standard power cycles, yun mismong combustion gases, yun na yung working fluid. Yan. In contrast, yung power plant, yung steam power plant yan ay external combustion engine. Yan. Kasi nga, heat is transferred from the combustion products to the working fluid. So, we have, sa air standard power cycles, we have the two-stroke cycle, one power stroke for every two stroke of the piston. Less efficient, pero ito yung ginagamit sa small na engine like sa motorcycle, chainsaw, lawnmower. We have the Otto Cycle, and this is based on a four-stroke cycle. And this is one power for every four stroke. Ito yung ginagamit sa spark plug ignition engines. Ginagamit gasoline as fuel. So, sa cars, sa boats, motorcycles din, yung iba yung pwede pang highway at saka sa light aircraft. And we have the Otto Cycle. So, this figure shows the ideal Otto Cycle. So, ito lang yun. May step siya. May 4 stages. Di ko na i-discuss masyado. Basically, yung step 1 to 2, yung isentropic compression. Tapos, constant volume heat addition, then isentropic expansion, then constant volume heat rejection. So, cycle siya. Ito yung itsura naman nung sa cylinder and piston setup niya. Pero, yan ay yung sa ideal Otto cycle. What if yung actual Otto cycle, ano itsura? Ito na yung itsura ng actual Otto cycle. So, mas complicated na. So, meron kang compression stroke, meron kang power or expansion stroke. So, dito may ignition, tapos meron kang exhaust stroke, may intake stroke. We also have the diesel cycle. So, diesel cycle is based on 4-stroke cycle. It employs compression heating ignition system. In diesel engines, the spark plug is replaced by fuel injection. So, kasi doon sa Otto cycle, meron kang spark plug. Sana. Yan, ito yung spark plug mo. Pero sa diesel, wala kang spark plug. Kasi dito yung diesel meron kang fuel injector. Pero sa gasoline engine, meron kang spark plug. Okay, yun yung difference ng gasoline engine sa diesel engine. Sa diesel engine, wala kang spark plug, may fuel injector ka. Automatic siya na pag nag-compress, magsaspark yung fuel, automatic siya. Sa gasoline engine, hindi siya automatic. Kailangan mo ng spark para magkaroon ng ignition. So, in diesel engine, yun nga, air is compressed during compression process. Tapos saka i-inject yung fuel. It's used in heavy trucks, heavy equipment, electric generating plant. This is the diagram, PV and TS diagram for the diesel cycle. So, meron kang isentropic compression, constant pressure heat addition, isentropic expansion, constant volume heat rejection. Lastly, meron tayong Brayton cycle. It's previously called gas turbine engine kasi meron siyang 3 components, the gas compressor, burner, and expansion turbine. Now, it's a cycle involving 2 constant pressure and 2 isentropic processes using a single phase working fluid. And it's the ideal cycle for simple gas turbine. Meron tayong dalawang klase, yung open Brayton cycle and closed Brayton cycle. This is the open Brayton cycle. Bakit siya sinabing open? Fresh air at ambient condition is drawn into the compressor where its temperature and pressure is raised. Then the high pressure air proceeds into the combustion chamber. The fuel is also injected in the combustion chamber. And then, fuel is burned at constant pressure, and the resulting high temperature gases enter the turbine where they expand to atmospheric pressure while producing power. So, yun. The exhaust gases leaving the turbine are thrown out. Ayun. So, yung mga exhaust gases, released to the environment. Difference naman ng Brayton closed cycle, okay, yung exhaust, umiikot siya. Kaya closed cycle. Pareho lang din, pero basically, meron kang cyclic na nangyayari. So, nasa-circulate yung exhaust gases. These are the equations na ginagamit for Brayton cycle. Okay. The efficiency, okay, yung ginagamit na kahawig lang ng, diba kapareho lang ng efficiency ng Carnot, pero yun, we can use CPDT to calculate for QC and QH. Next is yung definition ng backwork ratio. So, the backwork ratio, ginagamit to sa Brayton cycle, yung terminology na to, is the ratio of the compression work to the turbine. This is the compression work to the work of the turbine. So, di ba may compressor ka, tapos meron kang turbine. So, yung ratio ng compression work sa turbine work, that's the back work ratio. And it's usually 40 to 80%. Ayan. Okay, that ends our lecture for the power plant topic.